Students, welcome back to physics online session. So we were discussing about that combination of resistance. So in case of that combination of resistance, we got that effective resistance in series combination. So what's the connecting formula? R of S, which is equal to R1 plus of R2. What is the effect resistance in case of series combination? R of S, which is equal to R1 plus of R2, so on. It means that in case of series combination, so effective resistance is greater than the individual resistance. For example, let me take that two resistance were 1 ohm and 2 ohm here. These two resistors I made in a series connection. Series means end to end connection I made, right? So if I connect these two resistance in series combination, effective resistance is 3 ohm, right? So this effective resistance value is greater than the individual resistance in case of series combination. Wait a minute. Right, sir. So in case of series combination, effect resistance is always greater than the individual resistance. In series combination, current is remains the same. Total potential difference, which is equal to sum of the individual. So while calculating that branch potential difference, what is the connecting formula I am having? So generalized formula. So branch potential difference, which is equal to total potential into resistance of the branch divided by total resistance. So this is the connecting formula to find out that branch potential difference. Now we shall discuss that if I connect that two or more resistance in parallel combination, what is the connecting formula in case of parallel combination? First let me know that how to make that parallel connection, right? And then we can find out that what is the effect resistance in parallel combination, and in parallel combination which of the quantity will be remains the same. Such aspect we'll discuss in today's session, right? So we'll begins with the concept of parallel combination. Effect resistance in parallel combination. So first I will take that two resistance here. These two resistance I will make it in a parallel arrangement. For example, this is one resistor. This resistor having that resistance R1, and I will take that another resistor. This resistor having that resistance R2, right? Now look at here. This end, first resistor of the first end and second resistor of the first end, I will connect like this. I will connect to the common point, and second end of the first resistor and second end of the second resistor I will connect to one more common point, right? In case of that parallel combination, how to make that parallel connection here? All the elements are connected between two common points. So look at here. So first resistor and second resistors, I made it in one common point, and second end of the first resistor and second end of the second resistor I connected in another common point. In case of that parallel combination, all the elements are connected between two common points. Such kind of connection we can consider as parallel combination. Either it may be a resistor, either it may be a capacitor, or otherwise it may be a cells. So if you connect those cells, or if you connect those capacitors, or if you connect those resistors between two common points, such kind of combination I will take it as parallel connection, right? So end of this I will connect to battery. Let us take, this is positive terminal of the battery and this is negative terminal of the battery, right? Now suppose I amount of current is flowing from battery. Now that current is reaches to point A. So in this point A, whatever the current is, that current is getting branch here. So look at here, if current is reaches to point A, this current is getting divide here. This current I is getting divide into I1 and I2. Certain amount of current is flowing through the first resistor and remaining amount of current will get flow through the second resistor. So whatever the total current is there, so that total current is getting divided here. So in case of parallel combination, so we can consider that total current which is equal to sum of the individual, right? So I which is equal to I1 plus of I2 we shall consider. Now, in case of that parallel combination, potential at point A and potential at point B will be remains the same. In case of parallel combination, which of the quantity will be remain same? In parallel combination, potential difference is remain same. How the value of potential difference will be same? Why the current is going to getting branch here? So in order to get the thing, again I will take that two different pipes having that different diameter. Right? So these two pipes are connected in this fashion. If I pour certain amount of water, so the larger diameter of the pipe occupies that more quantity of water. In the similar aspect here, if you connect the two or more resistors in parallel combination, means the least resistance wire will occupy or will capture that more amount of current here. So look at here how that two different pipes having that different diameter, so will collect the different amount of water. In the similar aspect here, two wires I consider here. These two wires having that resistance R1 and R2. If R1 value is small, if the resistance value is small, means it allows that maximum amount of current. So in case of parallel combination, total current which is equal to sum of the individual potential at this point will be remains same. In parallel combination, which of the quantity will be remain same? In parallel combination, potential difference value is remains same. Now, so how to find out that effect resistance in parallel combination? Consider two resistor of resistance R1 and R2 are connected in parallel combination. Are connected in parallel combination. These two resistors are connected in parallel combination. So what is parallel connection here? So all the resistors are connected within two common points. So this kind of combination I will take it as parallel connection. So what you mean by that parallel connection here? All the circuit element, or simply you can consider all the resistors are connected between two common point. Two common point is known as parallel combination, right? In parallel combination, total current which is equal to sum of the individual. So in parallel combination, total current which is equal to sum of the individual. Total current is equal to, so total current is equal to sum of the individual. Is equal to sum of the individual. Sum of the individual we can consider. Let me write in terms of equation form. Total current I which is equal to I1 plus of I2, right? So from Ohm's law I can rewrite this equation. So from Ohm's law, V which is equal to I into R, I which is equal to V divided by R. Here resistance are in parallel combination. R of P I will take, and current through the first resistor. So V1 by R1 and V2 by R of 2. Let me take this as equation 2. Right? Now, wherever I term is there, just I will take it as V by R of P. I1 means V1 by R1. Instead of I2, I will take it as V2 by R of 2. So I will substitute, put equation 2 value in equation 1. Right? So I, which is equal to V divided by R of P. I1 means V1 by R1 plus half. I2 means V2 by R of 2. So as I said that in case of that parallel combination, potential difference value is remains the same. In parallel combination, potential difference value is remains same. Potential difference is remains same. So if potential difference value is remains same means I shall rewrite this equation, just I will name it as equation 3. Right? So if the potential difference value is remains same means, look at here, P which is equal to, or V1 V2 which is equal to V, then equation 3 becomes, right? So this equation 3 I can rewrite it as, so V divided by R of P. So instead of V1 I will take it as V I will take outside here, 1 by R1 plus of 1 by R of, here V term will getting cancel out. So 1 by R of P which is equal to 1 by R1 plus of 1 by R of 2. In case of that parallel combination, effect resistance in parallel combination, 1 by Rp which is equal to 1 by R1 plus of 1 by R2, or otherwise I can consider 1 by Rp which is equal to R1 into R2, R1 plus of R2 or R2 plus of R1, R of P which is equal to R1 into R2 divided by R1 plus of R2. This is the required expression for effective resistance in parallel combination, right? So again it will get disturbed. Sorry. Wait a minute. Sorry. So this is the expression for that effect resistance in parallel combination. Now in parallel combination, total potential difference which is equal to sum of the individual I said. Then what about that? Sorry. So in case of that parallel combination, so I said that total current which is equal to sum of the individual. Now let me find out that branch current here. So what is the amount of current is flowing through the first resistor and amount of current is flowing through the second resistor I want to find out. So before that, in case of parallel combination, so what is the effect resistance? R of P which is equal to R1 into R2 divided by R1 plus of R2. Let me take R1 value is 1 ohm, R2 value is 2 ohm. So if you connect these two are in parallel combination, what about the effect resistance? R of P which is equal to R1 into R2 divide by R1 plus of R2. So this is 2 by 3 ohm. In case of that parallel combination, effect resistance value is always less than the individual. Listen here. So 1 ohm and 2 ohm. If you connect these two resistors are in parallel combination, means whatever the effect resistance value is there, that effect resistance value will be less than the individual in case of parallel combination. Whereas in case of series combination, effect resistance will be greater than the individual resistance. In case of parallel combination, potential difference is remains the same, total current which is equal to sum of the individual. These are the 3 points we need to remember in case of parallel combination. Now let me find out that branch current here. In case of parallel combination, total current which is equal to sum of the individual, means I want to find out that branch current in parallel combination. Branch current in parallel combination, right? So in parallel combination, total current I which is equal to I1 plus of I2, right? So we know the thing, I which is equal to V by R, right? Then I1 means V1 by R1, so I2 means V2 by R of 2. So if potential difference value is remains same, means if V1 which is equal to V2, then this equation I can consider V by R which is equal to V1 by R1 plus of V1 by R of 2. So potential difference value is remains the same. So V divide by R, sorry, this one I can write as R only. So take it as I only, this one. I as it is I will consider. I which is equal to V1 I will take out common, 1 by R1 plus 1 by R of 2, right? Then just I will simplify this equation by getting that branch current value, right? So I which is equal to V1, 1 by R1 plus of 1 by R2 means R1 into R2 divided by R1 plus of R2, right? Then wherever V1 is there, I which is equal to V1 means you can consider that I1 into R1, R1 plus of R2 divided by R1 into R2. Here R1 term is getting cancelled out. So branch current I1 which is equal to what? I1 which is equal to I into R2 divided by R1 plus of R2. I1 which is equal to I into R2 divided by R1 plus of R2, or also I can rewrite it as I2 which is equal to what? I into R1 divided by R1 plus of R2. Then what is the generalized formula in case of that parallel combination branch current in order to find the branch current? So branch current which is equal to, I stands for total current, branch current which is equal to total current into resistance of the other branch. For example, I want to find out that amount of current in the first resistor, so I have to take that resistance of the second wire, so I into R2, so resistance of the other branch divided by total resistance. So what is the generalized formula I can say in case of branch current? Branch current which is equal to branch current which is equal to total current into resistance of the other branch divided by total resistance. resistance we have to consider, right? So what is the connecting formula? Branch current, which is equal to total current into resistance of the other branch divided by total resistance. So hope it clears. I will give an example here. Two resistor of that resistance 1 ohm and 2 ohm. These two are connected in parallel combination. So these two are connected in parallel combination, connected to battery, right? Positive and negative terminal of the battery. Let us take 5 ampere of current is flowing from the battery. From the battery 5 amps of current is flowing. Then I want to find out that I1 value and I2 value. So I1, which is equal to, look at here. So branch current, which is equal to total current, is 5 amp. So I want to find out that, so current through the first resistor, so I1 into R2. So R2 value is 2 ohm, right? Then R1 plus of R2. So this is the way to find out that branch current in case of parallel combination. So remaining thing will continue in next session. Tiffin sir.